Hey everybody, we are back today with part 2 of lesson 1.3. This will be the last lesson in the chapter, so yay, you made it through a whole chapter. Today's lesson will be on significant figures, so please pay attention as we go through the notes, fill in the blanks as needed, and like always, if you have any questions, let me know. Hey everybody, we are back and we are going to be discussing the second part to our third lesson of chapter 1, and that is using significant figures. We'll start out with 3 vocabulary words. The first one that we have is called precision. Precision is how close a set of data points are to one another. So in other words, how close is the data in relation to the other pieces of data that we have. That's the definition of precision. The next one that we're going to look at is a term that's called significant figures. And when we are looking at significant figures are the numbers that show the precision of a measured quantity. So in other words, how precise can we be with a particular set of measurements? Different tools will measure things with different degrees of precision. So sometimes if you have a ruler, for example, that only has the inches marked off and no other points on it other than the nearest whole inch, it's very hard to be any more precise than an inch whenever we are measuring there. So what would happen if something would fall in between, let's say, 2 inches and 3 inches? We would have to make a guess there. And that guess, maybe it's 2.5, that would be something that would indicate a possibility that we could be adding error to it. So significant figures are actually the number of known figures with certainty plus one estimated digit. The last term that we have is a term called accuracy. All right. Now, accuracy is a description of how close a measurement is to the true value of the quantity measured. So let's look at some examples, and we'll use a yard game of being able to toss some rings onto a post that's in the ground. In the first one that we have right here, this indicates good accuracy and good precision. The reason being is our accuracy is good because the target value, or the post, we've got all the rings around it. We say that this is precise because not only are the rings around the post, they are also very close to one another. Let's look at the second one right here. This indicates good accuracy because we've got the rings fairly close to the target, which is the post, but poor precision because our data points, or in this case the rings, are spread far apart from one another. The next one that we've got is poor accuracy and good precision. The reason that we have poor accuracy is because we are far away from the post, and the reason that we have good precision is because the rings are close together. In this case, if we were talking about data, the data points would all be close together for a series of measurements. And in the last thing that we have right here, we have poor accuracy. The reason it's poor accuracy is because all of the data points, or the rings, are spread far apart from one another. And then we also have poor precision. Let me backtrack on that. They are poor accuracy because they are far away from the post itself, and they are poor precision because all of the rings are far apart from one another. Now, we have some rules that occur when we add or subtract as far as significant figures are concerned. When we add or subtract using significant figures, we round our answer to the fewest digits there are after the decimal point in the problem. So if we had an example of 2.15 plus 1.15, we have 2 digits after the decimal here and 3 digits after the decimal here. So our answer has to be rounded to the fewest number after the decimal. So we would only carry 2 digits after the decimal in this answer. On the second type, when we multiply or divide, we round our answer to the fewest total number of significant digits there are in the problem. So let's say we had 4.5 times 2.105. Because there are 2 significant figures total in this problem, and there are 4 significant figures total in this problem, our answer can only have 2 digits in it as the total at the very end. And we'll do some practice with this in a moment. Okay, let's calculate the volume of a room that is 3.125 meters high, 4.25 meters wide, and 5.75 meters long. We're going to write the answer with the correct number of significant figures. First of all, we have to know the formula for volume. Volume of something that is three-dimensional is length times width times height. Okay, so we have length times width times height. So let's plug in our numbers. 3.125 times 4.25 times 5.75. Okay, the first step that we do is we punch these numbers into our calculator and we get a big calculator answer. So when we do this, we get 76.3671875. And to put a label on it, a meter times a meter times a meter is a meter cubed. Now, this is our point where we want to go and we want to round accordingly based on the rules for multiplication. Multiplication rules say we have to keep the fewest number of significant figures as there are in the number with the smallest amount. So let's look. If we count these, we have 4 significant figures. If we count these, we have 3, and these 3 again. So the fewest number are 3 significant figures. So we need to keep 1, 2, 3. So right here is where we need to make a decision if we should round. If the number in question is a 5 or greater, we will go ahead and round for our rules in this class. So this becomes 76.4 meters cubed. And that is our answer with the correct number of significant figures. Let's do one more set of practice problems that are kind of with multiplication and division, and then we'll practice a little bit of addition and subtraction. So in A, we have multiplication again, 12.65 meters times 42.1 meters. First thing we do is we multiply this in our calculator and we get a calculator answer, 532.565. Meters times meters equals meters cubed. Now we need to make a decision, and that decision is going to come from how many significant figures do we have total that are the fewest. 4 on the left, 3 on the right. We're going to keep 3 significant figures. So we're going to keep these 3, and we got to make a decision to round. So we are going to go ahead and round this to 533 meters squared. Okay, let's take a look at how we do B. B is division, so we have 3.244 meters divided by 1.4 seconds. We want to punch this into our calculator and get a full calculator answer, 2.317142.857, and our label is meters over seconds, or what you might have heard before as meters per second. Now, the multiplication and division rules are exactly the same, so we will have to come up here and count our numbers. There are 4 there and 2 there. So how many do we need in our answer? The answer is 2. So we have 1, 2, and we make a decision to round. Because it's a 1, we round it to 2.3 meters per second. Always have a label whenever a label is available. All right, we've covered multiplication and division, and let's do one example of an addition and subtraction. Okay, so I'm going to pull up another blank slide, and let's do a multiplication one. What if we had 1, 0.23 meters plus 1.554 meters plus 6.1 meters. Okay, so the first thing that we will do here is we're going to add these all up and we're going to get a calculator answer. 8.884 meters. Now, the rules for addition and subtraction are the same. It's the fewest total after the decimal. Here we have 2, here we have 3, here we have 1. So we need one digit after our decimal. Here is the digit after our decimal. Now we need to make a decision to round. 8.8 will get rounded to, oops, put that back up here. 8.8 meters, let's see, there we go. 8.884 meters will get rounded to 8.9 meters. All right, let's look at another one, and hopefully I don't accidentally erase the screen again. 56.2113 grams minus 2.211345 grams minus 6.123 grams. First thing we do is we get a calculator answer. 47.876955 grams. The next thing that we're going to do is we are going to make a decision of how many digits we need after the decimal. Here we have 4, here we have 6, and here we have 3. And the rules for addition, subtraction, being the same, say that we keep the same number of significant figures as there are after the decimal that has the smallest number of digits. So in this case, we need to keep 3 after our decimal. So we're going to use all of those numbers right there, but make a decision to round based on the 9. So this answer that we have right here will be 47.877 grams. That is how you do both of those. All right, that is the end of the lesson on significant figures. That concludes the chapter. In just a little bit, your teacher is going to come around and check your notes for this section to give you some points if you have them all completed. Let you know about a couple things that are coming up. We have a vocabulary quiz. The vocabulary quiz words are the words that are in the book that are highlighted. They're also the ones that you defined in your vocabulary worksheet at the beginning of the chapter. That's coming up on Thursday of this week, so please be ready for that. And then on Friday of this week, we have a test, and it is a chapter test, which we'll talk more about that later.